Hi everyone, in this video let's solve the Leetcode problem 567 permutation in string. So given two strings s1 and s2, we have to return true if s2 contains a permutation of s1 or false otherwise. So let me show you an example. If you have s1 as ab and s2 as eid ba o, so in this case we can see that there is a permutation of s1 and s2, and the order doesn't matter, but the the string s1 should be continuously present in s2. This should be true, but if you add s2 as ei d b o this way, so we can see that h2 indeed contains b and a, but it's not continuous, so it would be false. It's not a permutation of s1. So the typical approach that we use to solve this kind of problem is sliding window, and as an optimization, there's something called ruling hash, which I'll demonstrate shortly. So let's consider an example. S1 is equal to CAB, S2 is equal to DBA, CB A. Okay. So if we consider this, we have this as S1. We have to find permutation of this in S2. So one obvious thing you can notice is if length of S2 is less than length of S1, then we cannot have a permutation of S1 in S2 because there are not enough letters in S2 that can make up a permutation. So in this case, it's not true because length of S2 is greater than length of S1. So we are good to go. We can continue. So the first step that we do is we keep a hash map for all the letters and their frequency in for S1. So in this case, we would get C1, A1, B1. Okay. So now the second step is we we keep start of our window in S2 as 0, and then we iterate over uh, the index comma char in S2. So this is a bit of Python syntax which basically fetches our uh, index as a first element and the character as a second element from S2 for each character in S2. And now what we do is we basically set uh, another hash map called hash underscore s2 for s2, and in this as in when we find our character, as in when we go through the characters, we add it to our hash map. So in this case, our h2 would be dbacba, right? dbacba, this case. Okay, so when we are at here, so this would be our end, d is our end. So the hash map would contain d1 until now. Uh, but the thing is, like, right now our start is also here, our end is also at D, and unless we have at least three characters in our window in S2, we cannot possibly check if it's a permutation of S1, right? So we keep our win length as end minus start plus 1. So unless if win length is equal to length of S1, then we do something. Only when this is the case, else we just keep uh, continuing and moving to the next characters. So as you can see here, right? So in this case, what would happen is we have S1 as CAB, S2 as DBA, CBA. So in the first iteration, start would be here, end would also be here. So win length is equal to 1, which is not equal to 3, which is length of S1. So now we go to the next. Yeah, but before we go to the next one, so we just add hash S2 is equal to D1. Okay. So now we go to the next iteration of the for loop, and now E goes to the next character. So DBA, CBA. So here start. This will be our end. Oh no, sorry. This would be our end. Okay. So win length is equal to 2, which is not equal to 3 yet. But we add it to our hash map, which I'll explain why it's really useful. This is how the rolling hash method works. So we already have D1, and now we add B1. Okay. So then we go to third iteration, DBA, CBA. So this would be a start, this would be a end, and now we see win length is equal to 3, which is equal to length of s, which is 3. So first thing we do is we add it to our hash map, of course. So D1, B1, A1. Okay. Now, now that we have like three letters in S2 and RS1, just to reiterate, is CAB. We have a hash map for S1. We have a hash map for S2 as well. So now what we do is we check if hash of S1. You can do this in Python. It's allowed to check two hash maps, if the equality of two hash maps. Then we return true, is we have a permutation, right? Else we don't have hash map for S2 is DBA and for S1 is CAB, so they're not equal. So it comes to the else case. So now like the usual sliding window, right? So we have to merge start front. Okay, so DBA CBA. So our start moves front and would be here, and yeah, but instead of kind of at this stage, what we do in most of the problems is we first empty our h2 hash map. Okay, then we fill it up again with whatever is in the window between s and d. So whatever is in this window here, we fill it up again, right? So instead of this, we can do a neat trick, which is called rolling hash trick. We essentially, now we have only these two characters in the window, right? So let us just eliminate this from our hash map. That makes things much simpler, right? So we can just if there's only one character, then of course we just delete the whole key itself. So hash s2 of d. But we have more characters, right? So if there's another d here, so we may have we can just delete it, because then the frequency of this would also be the frequency of this would vanish, which is not correct. It would become 0. So we just do hash is to d. minus is equal to 1. So we do this, which essentially is same as saying that instead of using another hash map or emptying the hash map and using it for the second window, we slide our s front and we delete d from our hash map. So now that hash map becomes valid for this b and a. Okay, so now we do we do the same thing. So now we check if the window length here it's 2. You can see it's b and a, it's 2, which is not equal to 3. So we move our end front. So let me write here d b a c b a. So start here, end here. So move our end front. So now you can see that we add c, add it to our hash map. It's 2. So b1, a1, c1. Okay, now we have this. And then when we do a check, if hash s1, hash s2, I should find its equal, right? Because this is for s2, and for s1 we would have c1, a1, b1. So these two are actually equal, and hence we just return yeah, so we return true. If we actually had to print out the uh, permutation, then what we have to do is iterate through each element in our hashes to store in this, store in some result string, then we return this. But in our case, we just need to just say if there is one it permutation or not, right? So then once we find it, we return true. So this was how we work through the problem. And yeah, once the maximum time that we take would basically be the length of h2, right? Because that's the worst case time complexity is if we had to go all the way from starting to ending of h2. Similarly, is the space complexity, or yeah, let you can figure out the space complexity and put in the risk comments. I have only 23 subscribers, but if you're still watching, just it would be a really good practice for you as well. So you can figure it out, put it in the comment box, and now let's just return to the code. It's really simple. Or well, I have a space complex. I wrote it here by mistake. So it's O of 1 because uh, the both the counters S1, counter S1 and counter S2 can have maximum of 26 characters. Right? So from A to Z. So there may be only 26 slots in S1 and S2, and hence like we would have like a, a constant space complexity of O of 1. And the base case here is, like I mentioned, if length of S2 is less than length of S1, we return false. We keep two counters for S1 and S2, and we loop through each character of S1, and then we initialize a counter for it as S1 counter. Then we start the window, start is equal to 0. We yeah, so we go over each character in S2. If it's still not in S2 counter, then we initiate to 0. If it's already there, then we increase the frequency by 1, and the window size would basically be n minus start plus 1. If the window size is equal to length of S1, like I mentioned, then we are good to check if both the counters are equal. If they're equal, we have found our answer. But if the window size is not equal to length of S1, then we keep on iterating in S2, and yeah, we keep on iterating S2 until we reach the point where window size is actually equal to length of S1. So if the both the counters are not equal, and we see that uh, you know the the frequency of the start index of S2, if it's equal to 1, then we delete it from our counter itself. Otherwise, we decrement the count. Like show you. So here, right? So, so this was a start. This was a start here. Okay. Now, since the hash maps were not equal, right? So now we need to check if the frequency of this is 1 or not. So it's indeed 1, because in this TBA the frequency was 1. So we just delete this from the hash map. If it was not 1, if we had a DDA, then we would decrement the count of t by 1, which basically kind of removes this initial s from our hash map, or decrements this counter from the hash map. And then we move start plus is equal to 1, start from here, so from this point onwards. And yeah, so this is how it kind of works, like I showed you. And if we don't have any matches, once we iterate through S2, right, once we reach once our once a start pointer, mm, yeah, so once, so how did I write the code? Yeah, so once we reach to the end of S2 here, once end reaches the last character of S2, and we still not have found a window such that the counters are equal, we return false, since there's no permutation that exists. Alright, so this was all for the video, and thanks for watching. I'll see you in the next one. Bye.